Okay, so right now we're going to look at something called electric potential. Okay, now we kind of talked about something called potential before. We did that when we talked about energy. Now, so this time here, instead of talking about picking up a box and raising it up and putting it on top of a chair, a table, or whatever to increase its potential energy, we're going to talk about a couple of different things. We're going to talk about taking a charge. If we have a large object here and it's super positive, and then we take a little negative charge and put it over here, its relationship between the distance between these two will definitely affect the amount of energy that this guy's going to have. Now let's sit down and think about this, because if this one here is drawing it with a force, okay, so the farther that object is away, the longer the time it has to accelerate before it gets here. So that kind of makes sense. That's kind of a relationship between potential energy and kinetic energy that we had before. So our separation of charge is really going to affect the whole concept of our energy to do stuff. Now, sometimes we'll refer to a battery as a potential energy. So we're going to look at a couple of definitions. Electrical potential is equal to electrical potential energy divided by the amount of charge. Now, so let's take a look at a couple of things here. Now, this potential energy electric potential is going to have a new fancy name. It's going to be volt. Now, our voltage is going to be equal to our amount of energy, which is in joules, divided by our amount of charge, which we mentioned earlier is a coulomb. So our voltage is equal to our electrical potential energy, which is in joules, divided by our charge, which is in coulombs. Okay, so that's something we can work with now. Okay, guys, so one of the things that we're going to talk about now is a voltage. So when we think of a voltage source, one of the things that we normally think of as far as a voltage source or a source of a potential source, we normally think of something like a battery. So let's take a look at a battery. So a battery is just a basic box, right? Now, one of the things that's kind of cool or interesting about a box, our little box battery, is it's got a divider in the center of it. Now, this divider provides us with a barrier that stops the flow. Now, it prevents the electrons from moving from one location to another location, is a way of thinking about it. Now, it's a flow of charge, and then we call these things that do not allow charge to flow an insulator. Now, our standard battery, one of the things we normally see is two terminals, right? We normally think of a positive and a negative terminal. On one side of the battery, we load it up with electrons, or we put a chemical in there that produces massive amounts of electrons, depending on how we build things. A lot of times we'll use an acid type material there. Then on the other side, we have no electrons or very few electrons. Now, based upon what we studied with the electrostatics, we know that a negative charge and a positive charge are attracted. So what we do is we connect these two with a pipe to allow the flow, and that's called a conductor. We normally use a type of metal similar to copper. Now, once those guys are connected, our potential difference, or the ability to generate energy, because we're going to begin to move, starts happening, and then our electrons start flowing out from one side of the battery to the other. So they keep flowing, and they keep flowing, and eventually we'll get into what's called an equilibrium status. Now, we need to focus a little bit on this, and we need to think about what's going to happen. Now, once we've got this moving, we're pumping it from one location to another. We got to think about what's going to happen, okay? Because we had potential energy here. Now we've started stuff moving, so we need to take a look at that, okay? Okay, so what we're going to take a look at now is something called current. Now, current is going to involve the movement of something. It's going to involve the movement of a charge in a given amount of time. Okay, so that's what we're going to be focusing on. So let's say we have something of a charge of 5 in 1 second. So the current is 5 amps, or 5 coulombs per second. Okay, now current is measured in charge divided by the time. So Q stands for charge. Remember, that's measured in coulombs. Current is measured in amps. Time is measured in seconds. Okay, so it's a couple of things that we need to think of and remember. Okay? Okay, one of the things that we need to think about real quick is I noticed that some of the things we have to think about, our quantity of charge is directly related to the number of electrons that we have. So this represents the number of electrons, and then E is the charge of one electron. So when we think about that, we've got to remember that the charge on an electron is, so when we talk about this, so we have 1.6 times 10 to the negative 19th coulombs is the charge of one electron. So if you've got 2 electrons, you multiply that number by 2. If you've got 3 electrons, you multiply that number by 3. So a lot of that should come in handy on this.